Hello students, your Professor Dr. Mink, and welcome to another wonderful lecture for CSC122, Computer Science 1. The topic of the day is arrays. Much of this will be review, especially if you had me, hopefully if you had any of us, any of the professors who teach CSC 121, the prerequisite to this course, because I cover arrays extensively. So let's get started. This is the scope of this chapter on arrays, chapter 7 from Java Foundations. We will review array declaration and use, bounds checking, arrays as objects, arrays of objects, command line arguments, variable length parameter lists, and multi-dimensional arrays. Much of this, I'm going to say 75% of this is going to be review from the prerequisite course. An array is an ordered list of values. It has a name, a base type, and an index for each value stored in the array. So if an array is size 10, its index, it has 10 values. That means its index runs from 0 to n minus 1, which in this case would be 9. Each value in an array can be referenced using the array name followed by the index in brackets. So for example, the expression scores, and I use the term sub2, index 2 refers to the third value in the array. Score sub 0 being the first, score sub 1 being the second, score sub 2 being the third. And stored in the third indexed value, this index location of this array was the value 94. You'll see arrays depicted vertically or horizontally. That's just a way of representing them to help students understand the concept. So in this particular example, we have an array that size is, I'm waiting, you in the third row. Oh, sorry. We're not in class. The size of this array is 11, okay, because its indexes go from 0 to 10. There's the index on the left-hand side. I guess the name of this is height. Looks like it stores integers, and height sub 5 holds the value 69. An element or an indexed value can be assigned a value, printed, or used in a calculation. First example is we're assigning 89 to the index location 2 in scores sub 2. That would be the third index location. Here we're taking the value in scores, and we can use a variable for the index location. So I'm assuming first is an integer. It'd have to be integer that holds a value. Let's say it holds 3. So it'd be scores sub 3, whatever that value is, plus 2. So if in scores sub 3, there's a 94, we'd add 2, 96, and that would be then stored in scores sub 3 because first was 3. And it can be used in any type of expression, including a concatenated string for printing. The values stored in an array are called array elements. You'll also hear me use the term indexed variables. Okay, an index stores multiple values of the same type. That is the element type. You cannot store doubles and ints in the same array. The element type can be a primitive type or an object reference. Therefore, we can create an array of integers, an array of characters, an array of string objects, an array of coin objects, etc. In Java, the array itself is an object that must be instantiated. The scores array that we've been looking at so far can be declared as follows. Int brackets scores, and then we call the constructor new int 10. So this would declare an array object, an integer array object named scores that is capable of holding 10 integers. Note that the array type doesn't specify its size, but each object of that type has to have a specific size. So int sub or bracket scores is the object reference variable, and then it gets assigned an an array object of integers that is size 10. Here we're further dissecting the statement that declared the array on the previous slide. Okay, you've got the type of the array, double, int, float, whatever, followed by the brackets with no size. The array name equals constructor, new, double, and then you need a size. So on the left-hand side of this, we're creating the object reference variable, and the actual object is being created and assigned to that on the right-hand side. Here we have some other examples of array declarations. New float 500 declares or creates an array object of floats, 500 floats, and assigns the object reference variable prices. Boolean brackets flags creates an object reference variable to an array, and then we need to use the constructor to assign that new object to that object reference variable. And then there's an array of 1,750 characters being created in the last statement. As you already know from being pounded with this information in the prerequisite course for this course, for loops and arrays, and if you took my course, you'd hear me say for loops and arrays go together like chocolate and peanut butter. That was a commercial from my generation. But yeah, for loops are perfect for processing arrays. And this for loop from int score to scores, system out.println score. This is only appropriate when processing all elements from the lowest index to the highest index. This program demonstrates creation, initialization, and manipulation of an integer array object. This should be 90% review. The syntax for most of these statements is so similar to the syntax we learned in the prerequisite course. So, declaring a final or a constant 15 multiple 10. A new integer array object named list. Size is 15, so it will have index elements 0 through 14. Name will be list. So for loop for index 0, less than limit, index plus 1, index plus plus, list sub index equals index times multiple. So we're going to get a 0, 10, 20, 30, 40, 50, 60, 70, up to 140. Then we're going to change one indexed element, element 5, which is the 6th index variable stored in the index array object, to 999. And then we're going to use that special for int value list to print out the entire array. And I've already run this, but I'll run it again. And there we see 0, 10, up to 140. Like I said, this is mostly review for all of you. This diagram shows 4 state snapshots of the array. First is the array is created with 15 elements indexed from 0 to 14, although nothing stored. After 3 iterations of the first loop, in which we're multiplying the index number times 10, we have 0, 10, and 20. After we complete the first loop, the array, the integer array object is fully initialized with 15 integers. Then we change the value of index element number 5 to 999. Once an array is created, it has a fixed size, and an index used in any reference must specify a valid element. And we know, because we all took the prerequisite course to this one, that if the size is 10 and you use an index of 10, you're going to get an error. So the index value must be 0 to size minus 1, and the Java interpreter throws an array index out of bounds exception if an array index is out of bounds. It's not between 0 and size minus 1. And this is called automatic bounds checking. This is total review and expands upon what I just described. Here's an example, an array named codes that holds 100 values. It can only be indexed, or the indexed elements can only be referenced using 0 to 99. But it's very common for to have an out of bound error, which is off by 1. If you, for example, if you specify 100 as inclusive in a boundary condition for a for loop, and there's an example. So we're going from index 0, it should be index less than 100, but instead it's coded index less than or equal to 100. So therefore, this for loop is going to try to reference an out of bound or an illegal index number, which is 100. Every array object has a public constant named length that stores the size of the array, and it's referenced using the array name scores.length. Length holds the number of elements, not the largest index. They are not the same. The largest index is scores.length minus 1. This program demonstrates array index processing. We're going to need the java.util.scanner library because we're going to be soliciting input from the user. So, new scanner object connected to system.in. A new double array object that holds 10 doubles, and then we system.out.println, the size of the array is, and we use numbers.length, the constant that holds the length. And then we've got a for loop for index equals 0, index less than numbers.length less than. So numbers.length is going to be 10, so we'll go to 9. Index plus plus, system.out, print enter number plus index plus 1, because we're going to start at 0. And then it will use the scanner to get the next double and store it in index, which is the counter for this for loop. Then it will print the numbers in reverse order. For loop index equals numbers dot length minus 1. So we'll start at length minus 1, which is the highest index. Index greater than or equal to 0, because we're going to go to 0 inclusively. Index minus minus. And then system.out.print numbers index plus space. Run this. So it asks us for 10 integers. I'll give them in reverse order. So we'll say 10.19.2, just because they're doubles. 8.3, 7.4, 6.5, 5.6, 4.7, 3.8, 2.9, and 1.0. And then you can see the numbers in reverse order. Pretty straightforward. Thanks for watching, and as always, this will be in the timeline for Canvas. This program uses two array objects. They're both integer array objects, and let's walk through it. It's called letter count. We've got a final or a constant num_chars equals 26, a new scanner object. Here's our two new array objects, char called current and an integer called other, initialized to 0. We prompt the user to enter a sentence. The entire sentence using scan.nextLine is stored into a string named line. Now we're going to count the number of each letter occurrences in line. So for int ch equals 0, ch less than line.length, which will be the length of the line, and our index will be 0 to 1 minus length. Ch plus plus, current equals line dot caret ch, caret 0, caret 1. This is a pretty cool way they do it. If current is greater than uppercase A and current is less than or equal to uppercase Z, upper, and then the index is calculated by current minus A. So if it's a B, B minus A will equal 1. If it's an A, A minus 0, A minus A is 0. If it's a Z, Z minus A will be 25, etc. So, and it just simply increments the index at which the letter matches. And then we just simply print it all out. I'll go run this for you real quick. Make the output a little larger for you. Enter a sentence. This is a simple sentence. Enter. So on the uppercase, there should only be one. Oh, I'm sorry. I accidentally put an uppercase S in sentence. That was a mistake, but it caught it anyway. So S1, T1, A1, C1, E4. It's a simple sentence. Yes, that's correct. I3 and 2. So anyway, as always, I'll place this file in the timeline for Canvas. It's really important that you understand what's going on behind the scenes. You download it, run it, etc. Here we have an alternate array syntax. The bracket can be associated with the element type or with the name of the array. So therefore, these two declarations are equivalent. Float brackets prices, float prices bracket. As we learned in C++ in the prerequisite course, an initializer list can be used to instantiate and fill an array in one step. Here are some examples. Int brackets units, and we will fill it with, looks like 1, 2, 3, 4, 5, 10 elements. So its size will be set at 10. Second example with char letter grades. Note that in Java, when an initializer list is used during the declaration, the new operator is not used, and no size value is specified. The size is implicit from the size of the initializer list. I'm just going to leave this code here. I'm not going to run it in the compiler because it's such a simple example of a program that uses an initializer list for an array. And so here we're using an initializer list to declare an integer array object, and we're going to initialize it with 2, 3, 5, 7, 11, 13, 17, and 19. So its size or length will be 2, 3, 4, 5, 6, 7, 8. I had to count them, 8, and you can see the rest is pretty straightforward. Arrays can be passed as a parameter to a method, and like any other object, the reference to the array is passed, which means the formal and actual parameters become aliases, are aliases of each other. Therefore, if you change an array element within the method, you change the original. It's not a copy. So an individual array element can be passed to a method as well, in which case the type of the formal parameter is the same as the element type. In Java, an array is an object, and an array can hold objects as elements. The array name is simply an object reference variable. So this is another way to depict an array. Weight is a reference variable to the array, and it actually holds the address of the element 0. So an array of objects really holds object references. And here we have a declaration that reserves space to store 5 references to 5 different string objects. It does not create the string objects themselves. Initially, an array of objects holds null references. Each object stored in an array must be instantiated separately with a constructor. Here we have 2 depictions of an array. After initial creation, an array holds null references, and each element is a reference to an object that needs to be instantiated. So we just looked at an array of strings. Keep in mind that a string object can be created using literals. The following declaration creates an array object called verbs and fills it with 4 string objects created using literals. String, brackets, verbs, play, work, eat, sleep. So next we're going to look at an example that creates an array of grade objects, each with a string representation and a numeric lower bound. This application demonstrates. Now we're going to take a look at an example that implements an array of objects. And in this example, we store a collection of CD objects, obviously using an array. So let's take a look at the code next. This is an application that creates a collection of CDs, and it's called CD collection, which is an object, and that adds CDs to it, and each CD is an object. So this will be an array of objects. So let's start by looking first at a CD. Here is the CD class, and a CD object has some private data, string, title, artist, double cost, and int number of tracks. And here's the constructor, and each CD has a title, artist, cost, and tracks. Pretty straightforward. Now let's take a look at CD collection. CD collection has an array of CDs called collection, private int count, double total cost. So collection equals new CD, and the size is 100. So a collection, as defined here, can hold up to, it's an array that can hold up to 100 CD objects. Got a method called add CD, title, artist, cost, tracks, and if count equals the collection.length, then we'll call another method called increase size. Got the toString method. Here's increase size. This increases the capacity of the collection by creating a larger array and copying the existing collection into it. So here's the application which pulls this all together. It's named Tunes. It's got a main. CD collection music equals new CD collection. And we call the add CD method. And we're adding Stormfront by Billy Joel, which is $14.95 and has 10 tracks. Come On Over by Shania Twain, $14.95, 16 tracks, etc., etc. And then we'll print the collection. And then we'll add two more and we'll print the collection. So let's run this file. There you go. Number of CDs 4, total cost. Here's the CD list, and then a new run when we add two more. 6 CDs, total cost, average cost, and the list. As always, I'm going to place the application and the two class definitions in the Canvas timeline, and I expect you to download them, run these, play around with them, and get an idea of what's going on behind the scenes. You probably noticed that the prototype of the main method indicates that it takes an array of string objects as a parameter. We've not used this before. These values come from command line arguments that are provided when when JVM, the Java Virtual Machine, is invoked. So, for example, the following invocation of the interpreter passes 3 string objects into main. We're assuming the Java program is named state eval, that it's been compiled. So to run it from the command line, and I'm gonna do a video in just a minute and show you how to run a Java program from the command line. In this case, we're passing to state eval during invocation 3 strings, Pennsylvania, Texas, and Arizona. And they're going to be stored at indexes 0, 1, and 2 of the array parameter of main method. So just hang on a second and we'll run, we'll edit, we'll compile, and we'll run a small program from the command line. I'm going to show you a simple program I wrote, just placed it in a directory on my system, and I actually wrote it in Notepad and just saved it as sample.java. Here is the program, just a public class sample, has our prototypical public static void main string array of an array of strings named args. And so if I run this, I'm going to compile and run this from the command line. And you could do this as long as you have your Windows environment variables set up with a path to the JDK. That's pretty simple to do, and I'll explain that in a different video. So here, if I run this and I pass, along with the name, I pass 2 arguments. Let's just say 10 and 20. They will be stored in arg sub 0 and arg sub 1. So, and if they are in the format that can be cast or parsed to an integer, which I'm going to do that, we'll use integer.parseInt arg sub 0 and assign it to an integer a. We'll take integer.parseInt arg sub 1 and assign it to integer b, and then I'll simply declare an integer c and add a plus b, system.out.println, sum of the 2 numbers is, and I'll add c to it. I've already compiled this, but I'll do it again. There's how you compile it. Won't do anything. And then Java, and I'll pass 10 and 20. And there you go. If I go back and, well, I'm not going to do that. I could do it again. Pass 10 and 2000. There you go. So I hope this was helpful. Thanks for watching. Have a great day. Let's move forward. Next topic is variable length parameter lists. We've already discussed how to overload a method to accept different numbers of parameters, which is one way to handle a variable length parameter list. There's another more flexible way. So let's assume we wanted to create a method that processed a different amount of data from one invocation to the next. Let's say a method called average that returns the average of a set of integer parameters passed to it. And we could pass 3 parameters, we could pass 6 parameters, 10 parameters, etc. Well, using overloaded methods would be awkward, cumbersome, time-consuming. We'd need to have a method for every possible number of parameters we'd be passing to that. So let's look at a different way, a more efficient way to do this in Java. As I just mentioned, overloading versions of the average method could accomplish this, but we'd need an overloaded method for every single number of parameters. We could define the method to accept an array of integers. However, we'd have to create the array, store the integers prior to calling the method each time. Instead of these two ways, Java provides a way to create variable length parameter lists that incorporate an array. Using special syntax in the formal parameter list, a method can be defined that accepts any number of parameters as long as they're the same data type. So each time we call the method, the parameters are placed into an array, and that's all handled. The memory management for this is all handled behind the scenes. So here we have an example of a variable length parameter list for a public void method named print names. We have the type of the array element, which in this case is a string. ... indicates a variable number of parameters, and then we give it the array name. So it creates an array of strings, and the length is variable. And let's take a closer look at some coded examples. This is our first look at a method named average that has a variable length parameter list. Average returns the average of a list of floating point or double values. Take a close look at this. We're going to have a coded solution that I'm going to demonstrate in just a minute or two. In a variable length parameter list, the data type of the parameter can be any of the primitive data types or an object. And we're going to, as I mentioned, we're going to see a full coded solution that implements a variable parameter list of objects in just a few minutes. Hang in there, I promise. We're getting there. A method that accepts a variable number of parameters can also accept other single parameters. So here's an example of a method that accepts an int, a string object, and a variable number of double values into an array called nums. Some more rules governing variable length parameter list. The varying number of parameters must come last in the formal argument. So you can have single object, but the varying number of parameters, the variable list, has to come last in the parameter list. And a method cannot accept two sets of varying parameters. It's limited to one set of variable parameters. And constructors can also be set up to accept a variable number of parameters. As promised, here's a coded solution that includes a class named family that has a constructor allowing us to create a new family object. The only data it has is an array of string names, or members, I should say. So you just pass it a variable parameter list of strings, which corresponds to names, and it will add those to the array of members. And it obviously has a toString method. So let's take a look at the application that utilizes or demonstrates this. So we have public class variable parameters. In our main, we simply declare two new families, family objects, one named Lewis and one named Camden. And in the parameter list for the Lewis family, we're passing 1, 2, 3, 4, 5, 6 strings for the names of the family members. For Camden, we're passing 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to print Lewis and print Camden. So I'll run this. And there we go. So John, Sharon, Justin, Kayla, Nathan, Samantha, and the second family has Stephen, Annie, Matt, Mary, Simon, Lucy, Ruthie, Sam, David. As always, this will be in the timeline in Canvas. You want to download this and take a look for yourself. All of the arrays we've discussed so far are one-dimensional arrays. They have a single list of indexed locations, and it stores a list of elements. A two-dimensional array can be thought of as a table of elements with rows and columns. It is an array of arrays. So as I mentioned previously, in Java, a two-dimensional array is an array of arrays. A two-dimensional array is declared by specifying the size of each dimension separately. So here we've got the constructor to declare a two-dimensional array of integers whose name is score. And it's going to be a 12 by 50 array, which means it will hold 600 elements. Each array element is referenced by using two index values. So value equals scores 3, 6 will take the fourth row and the sixth column. I'm sorry, the seventh column. Remember, it's a zero-based numbering system. 0, 1, 2, 3, 4, and 0 through 6 is 7. The array stored in one row can be specified using one index. Next, we explore a Java application that implements a two-dimensional array. For new public class 2D array has a main function in it, and in the main method, wrong programming language, we declare a new integer array named table that is 5 by 10, 5 rows, 10 columns. And then we're going to load the table with values with a for loop. And as you recall from the prerequisite course, for loops and arrays go together. And if you took my class, they go together like chocolate and peanut butter, which is a reference to an old commercial. So for int row equals 0, row less than table.length, row plus plus. We're going to start at 0 and go the entire length of rows, which will be 0. Well, the length will be 5. So we'll go 0 to 4. And then for columns, column 0, column less than table row.length, okay, column plus plus, and table row subcolumn, subrow subcolumn equals row times 10 plus column. So row 0 times 10 plus 0 will be 0. Okay. Row 1 times 10 plus column 0, 10. And you can see the results here. And then we just simply use a for loop to print the entire array again. And I've already run this and you can see my results, but I'll, just for the sake of doing it, I'll run it again. And there you go. Now, obviously you're going to need to download this, take a look at it, take a very close look at the structure of these for loops to make sure you understand how we're using length for the columns and rows, etc. syntax of various expressions and a description of those. So table int bracket bracket is a two-dimensional array of integers or an array of integer arrays. Table sub 5, okay, is an array of integers. Table sub 5 sub 12 is a reference to an integer at the 6th and 13th location, row column, respectively. Here we take a look at an application that demonstrates the use of a two-dimensional array. I'll explain what this application does. There are 4 soda flavors, or sodas, soda types, that are ranked from 1 to 5 by 10 different people. And the scores are stored in a two-dimensional array that is manually or hard-coded initialized. So for each soda, there is a row. I'm sorry, for each soda there's a row, and for each person there's a column. So for example, soda sub-0 ranked by person sub-0 received a 3. Now you'll see we're going to manipulate the numbering so that it actually doesn't say soda 0 and person 0, but you just add 1 when you're printing them out. So soda sub-0 was ranked 3, 4, 5, 2, 1, 4, 3, 2, 4, 4 by the 10 people that ranked that soda. Then soda number 1, or the second soda, soda sub 1, received those rankings. And you can see the 4th soda, soda sub 3, received pretty low rankings. So we simply have this for loop, okay, to calculate these averages. And for soda sub-0 to soda less than sodas, for in-person equals 0, in-person less than people, soda, sum, soda, right? A new array, plus equals scores, soda person. Person sum, person, plus equals scores, soda person. We set the decimal format to be 1 decimal place to the right of the decimal point for floats and doubles. And then we print line averages, and for soda equals 0, soda less than soda, soda plus plus, system.println soda plus 1, and then we format soda sum divided by people. And then we have, for the persons, 0 to persons less than people, person plus plus. And here's how we get from 0 to 1 and from 9 to 10. And if I run this, you'll see. Now, if we were in class, we'd be running this, we'd be changing some numbers, and we'd be looking at this. But because this is an online course, I really need you to download this, run it, and take a close look at what's happening and modify some of the values here. So soda number 1 had a ranking of 3.2 for those 10 people. Soda number 2 had a 2.6. Soda number 3, 4.2. And soda number 4, which we noticed in the last row, had some low rankings, a lot of 1s. And then here's how each person ranked on average. Person number 1 ranked 2.2, 3.5, etc. Person number 7 didn't like very many sodas. His average ranking for all 4 sodas was 2. Anyway, you know what to do with the files, and you know where to get them. I've taught multidimensional arrays in multiple languages over many years, And I can tell you, once you get beyond a two-dimensional array, things get a little bit abstract. An array with more than one dimension is a multi-dimensional array. And that includes 2, 3, 4, etc. dimensions. Each dimension subdivides the previous one into the specified number of elements. Each dimension has its own length constant. Because each dimension is an array of array references, the arrays within one dimension can be of different lengths. These are called ragged arrays, yes, and it is a ragged concept to grasp. I've only once ever worked with a multi-dimensional array that was beyond 2, and that was 3, and it was many years ago, and it is a very complex and abstract concept. So here's one way to visualize a 4-dimensional array. We have state, university, college, and department. As I mentioned earlier, 2-dimensional arrays are very common. And can you tell me, and if you had me before for the prerequisite course, you know the answer to this, but what is the most common application that implements a two-dimensional array? You in the third row, with your hand up. Yes, it is Excel as a 2-dimensional array. But beyond that, usually an array has other objects involved. Next, we're going to take a look at an example that uses an array of color objects. And when the mouse button is clicked, a color dot is displayed. And a double click clears the window. Let's take a look at the application now. In this application, we're going to demonstrate the use of an array of color objects and the capture of a single versus a double mouse click. Obviously, it's a Java FX application. You can see by all the imports. So we have a public class dots that extends application. And then we have an array named color list of color objects. And it's initialized to color.red, color.cyan, color.magenta, yellow, lime, and white. So this array of color objects will hold 1, 2, 3, 4, 5, 6 color objects. Some variables: color index is 0, count is 0, count text is a text object, and we've got our root group. So we're going to set our count text new text object at 20, 30. Remember, those are coordinates, and count will be 0. Calling a font 18, and the color will be white. New group, name root, and we're going to add count text to it. New scene, we're going to add root, be 400 by 300, and it'll be black. And then here is our call to our event handler for mouse click. And each time there's a mouse click event, if the event dot get click count is equivalent to 2, which means a double click, we're going to clear everything else. We're going to create a new circle object. We're going to get the X and the Y from the event getX method, and it will be a diameter or radius, whatever that is, of 10. It's the size of the circle. And then we're going to use the setFill method to go to color list and get our color index. Remember, color index starts at 0, and we're going to add the circle to the root. And then we'll simply increment the color index within the length and add our count. And this is pretty straightforward if you understand all the concepts we've covered so far. So let me run this and you'll see what happens. It'll allow us to create on single mouse clicks new instances of the circle object and it will draw the color of the circle object from a color object, which is an array of colors. So let's run this. So our count is 0. I click once, our count goes to 1, and it goes to red. And you'll see it will cycle through those 6 colors. And now we'll start over. And the mod keeps us within that palette. And then all I need to do is double click and it clears everything. Pretty cool. Hope you enjoyed it. You know what to do with the files. Run them. Make sure you understand what's going on behind the scenes. Ask me any questions. It's a critical component of this online course. We're going to wrap up this lecture on arrays by looking at a very cool application called the Jukebox. It implements a choice box that lets the user select one of several options from a drop-down menu. And in the Jukebox application, we use this to allow the user to select a song from the choice box. The play and stop buttons control the song playback, and the song names and the audio clips are held in arrays. It really is a great application. I'm going to put all the files you need, including the WAV files, which you just have to drag into the project, into the application. Drag it into the top level file, and it'll go into the right place. I love this about Java. So let's take a close look at it running. And obviously, I want you to download this, and it is kind of the culmination of this lecture. So, without further ado, let's take a look at this as the culmination. This application is the culmination of this lecture. You'll see it's a JavaFX application, and you're going to see some more JavaFX libraries. You're going to need, here's a choice box, here's audio clip. I'm trying to see if any IO file. Yeah, some other ones that we haven't used before. So basically, we're going to declare a string array named names, and we're going to hold the names of, I think it's 8 or 9. 1, 2, 3, 4, 5, 6, 7. 7 audio files. These are WAV and MP3 files that are going to be played through the audio clip with the audio clip library. And we also are going to have an array of files named audio files, and that will actually hold the file objects that hold the WAV. Yeah, there is one MP3 WAV and 2 MP3 files. WAV and MP3 files. And then we're going to simply, all the rest of this is the JavaFX setup, the button adding to the group, VBox, etc. I'm not going to spend an inordinate amount of time going over all the JavaFX controls that we've already covered. I'm going to run this for you and show you okay, so basically we're going to select the name, okay, and that will correspond to the index of the name in the array, and that same index will be used to find the WAV file in the other array. So here you go. And the audio file class provides the support for all of these WAV and MP3 files. We've got the Jeopardy theme. So hopefully this will pique your interest. I know young people like music. Believe it or not, old people like me like music too. And this is a very cool application. Please download this file and take a very close look at this. Make sure you understand what's going on behind the scenes. And that, my friends, is the end of the lecture on arrays. Hope you enjoyed it. Thanks for watching. Have a great day. And obviously, if you have any questions, you know how to get a hold of me. Take care.